Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ in Narre Warren South. We're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television ATV repeater, VK3RTV, digital channel 1, full HT, which I don't know if it's on BATC, but you can also view the video stream on Discord, on my Discord channel. If you install Discord and register, go to my qrz.com page for VK3 EKH, and I provide a link to be able to view the HD stream and also the chat room. We also have an email address, vk3ekh@gmail.com, vk3ekh@gmail.com. And we're also on YouTube. Just trying to bring up my, where is my caption there? We're also on YouTube, hopefully with some degree of stability tonight. YouTube runs about 20 seconds behind, so that's the only issue that we have with YouTube, basically. So if you're listening to me waffle on, describing things, the vision on YouTube can be delayed somewhat. That's why I provide Discord, because Discord is less than a second delay, and it's far better to catch up with visions. Anyway, we're warming up here. 25th of October, month is almost over, and how quick the year is going. It's 8.8 degrees here in Narre Warren South, virtually no wind, and it is the last throes of, I think, winter kick in and still here in Melbourne. But anyway, we have the tower, my Nelly Tower is raised to the full height, so the 80 metre inverted V dipole is at its full extension. So that may just help getting my signal out a little bit better than it has been over the last few weeks. But it is 80 metres after all. All right. We have a few things tonight. We have a solar report from Tamitha Scove, our space weather woman. It only goes for 8 minutes, so it's only a very short report, but it's about 20 hours ago that she released that, so it's fairly current. Having said that, this broadcast is been running since 1988, so I'm pretty tired. Anyway, it's been going since 88, and the first 20 years was conducted by Russell Ward, VK3DRW. Thanks, Russell, if you're listening. Hope you are. And I took over the microphone some 12 odd years ago, so I've got a few more years to catch up to Russell's record, so we'll be here for a little bit longer. The ASV, the Astronomical Society of Victoria, and of course VK3 EKH is the official call sign for the society, is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our two metropolitan locations, the Morley Community Village and the Melbourne Observatory. And we host monthly Astro Talks at the Herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during our Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory as well. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's park and streets and schools. If you check the calendar on the ASV website for details, you can find information about attending these events and when they're scheduled to occur, depending on the weather. The ASV is currently involved in a number of major projects. They are involved in the restoration of the Great Melbourne Telescope and also currently working on the installation of a series of remote telescopes at our dark sky site, which, once complete, will be accessible to our members for general use. Thanks to a generous donations from various members and long-standing respected members, the Leon Mao dark sky site, located north of Melbourne, has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope at the observatory at the dark sky site. And it makes use of existing telescopes at the Melbourne Observatory during some section meetings, and our members' nights, which are held once a month at the observatory. There's also an 8.5 fully steerable radio telescope located on the dark sky site, which is all part of the radio astronomy section. If you wish to be involved with that, get in contact with the section director. An annual yearbook is supplied to members, as well as a bi-monthly newsletter called Crux, which all members are welcome to contribute to. There's also a weekly, if not fortnightly, electronic magazine or newsletter that's published via the ASV via email to members, just to keep members abreast of what might be coming up in the following week or so, especially keeping people abreast of what section meetings are coming up. The ASV has a logo, which is the Southern Cross and the pointer stars, and it has a motto which is written in Latin, which when translated is "This way to the stars." The ASV, can't actually show that. Or did I? Oh, there we go. Yeah, this is what I think I showed last week. That motto, which is that, although it's not, doesn't have the Latin thing on it. I don't know where the. No, it doesn't matter. You'll just have to take my word for it. The ASV is governed by a set of rules which should be read before applying for membership. The document is apparently downloadable from the website. If you click on, there's a little link here that says "clicking here" under the About Us tab, and that should take you to that document, although I don't think it does. Any person or organisation with an interest in astronomy may apply for membership of the society. Yes, so all information can be found from the ASV website at www.asv.org.au, and all will be revealed. I am not working tomorrow, so I can be up till 3 o'clock in the morning if I so desire. I probably will. Just before I go on to some other articles that I've got here, I was going to read this out last week, but I thought no, I'll keep this over. I'm a member of the Planetary Society. They release or publish something called the Planetary Report, and the Planetary Society was one of these things that were formed by Carl Sagan and a few others that were around at the time. And the Planetary Society actually has quite a lot of involvement in various things to do with getting certain projects done at NASA. But apart from all that, the latest Planetary Society magazine has come through. I'll just hold it up to the visions here so you can see what it is that I'm talking about. And it's only, you can see that the search for life there is something I'm about to read, straight from the Z magazine. So it only goes for a few minutes, but I thought I might just give this a bit of a burl before I go on to the other things here. It's called Earthlings as Aliens, looking at life on Earth from another perspective, by Kate Howells. Part of what makes the search for life so fascinating is the way it contextualizes our existence here on Earth. If there is indeed intelligent life out there, those beings may be searching for us, just as we are searching for them. So, if aliens were to detect our presence, what might they find? Imagine an alien civilization light years away from Earth, at about the same level of technological development as humans. They may detect Earth's existence, an exoplanet from their perspective. They'd know that it is at the right distance from the Sun to support liquid water on the planet's surface, and if those aliens were water-based life forms like us, they might see this as a promising sign of habitability. If they focused their observations on us using an instrument akin to the James Webb Space Telescope or Habitable Worlds Observatory, they would potentially analyse our atmosphere and discover oxygen, a potential sign of biological activity, and perhaps industrial pollutants, a good indicator of technological activity. If they pointed radio telescopes at us, they might pick up transmissions we've sent out over the years. Another way aliens could discover evidence of human activity is through artifacts we've sent into space. The Voyager and Pioneer probes are equipped with messages for any beings who might encounter them along their way, along after they leave our solar system. Although the chances are slim that they'd be found in the vastness, emptiness of space, it's still possible. Some intelligent space exploring aliens could someday, I'll just read that again, some intelligent, space exploring aliens could someday find these artifacts and learn about Earth, its creatures and human cultures. The Lucy spacecraft is a different kind of artifact. Right now, Lucy is on its way to study the Jupiter Trojans, group of asteroids that share Jupiter's orbit around the Sun. After it completes its study of its targets, Lucy will continue to orbit the Sun for millions of years. It carries a sort of time capsule from Earth, just in case it's someday discovered by alien species that comes to our solar system in search of us, only to find that humans have long since gone extinct. This possibility may sound bleak, but it's another avenue for something deeply meaningful. Somehow, someday, our species and its capabilities might come to be known by others who share our most fundamental characteristics, life. I just thought there was something in that for all of us. Transmission spectrum of an Earth-like exoplanet. Yes. There's a little chart here, a little graph, a little chart recording. It's a transmission spectrum of an Earth-like exoplanet. So one end's the red, middle is near infrared and mid-infrared, and it sort of kind of gives you a bit of a graph there for those watching TV. A little bit closer to the screen camera perhaps. Anyway, so there it is. That's just the beginning article from the planetary report. And actually, its theme is a little along aliens. So there's actually a few interesting articles in there. But that's the planetary report, and I would urge anybody that's got an interest in the stars and the universe and what's going on to look at the Planetary Society. They have a podcast as well that runs. And, Carl Sagan kicked that off when he was around. And I figured that was one of the good reasons to become a member of that little group. You're tuned to ASV, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Well, it appears that the Sun has reached solar maximum, according to NASA and NOAA scientists. There's just one picture associated with this article. So let me see if I can bring that up. I wonder if I can bring that up in. No, I won't bother right now. Let me see, where is it? There it is. So associated with this article, Aurora watchers. Actually, let me just check my audio level. 1, 2, 3, 4, 5. Yep, that's okay. I just wanted to make sure that I'm not overdriving YouTube, assuming that YouTube is still running. Mumble. Okay. Auroral watchers and sun gazers take heart. Our star could remain at this level of activity for another year. But nevertheless, in a teleconference on October 15, representatives from NASA and the National Oceanic and Atmospheric Administration, NOAA, announced that the Sun has reached the peak level in its current cycle of activity. The 25th for which humans have kept detailed records. The 25th cycle has been far more active than previous one, especially this year when auroral shows have delighted sky watchers around the world. Solar cycles last roughly 11 years, moving slowly between periods of high activity, which can include sunspots, solar flares, coronal mass ejections, and more, and calmer, less active periods. The cycles are uneven and difficult to predict, though. Previous cycles have lasted as little as 9 or as long as 14 years. And day-to-day solar weather is just as difficult to predict as earthly weather. The metric by which solar cycles are measured relies on counting sunspots, which are dark areas on the sun that are cooler than their surroundings. They usually last days to weeks and often appear in groups. They also correlate to many other kinds of solar weather, all of which stem from tangles and knots of the sun's powerful magnetic field. Indeed, the solar cycle is an indication of when the sun, which is a giant magnet, flips its polarity. In its quieter phases, the sun is a well-behaved dipole, and that is a magnet with a positive and negative pole, like a bar magnet. But over the course of a solar cycle, the sun's outer layers are churned by a phenomenon called differential rotation. The fact that the sun's plasma rotates faster at its equator than at its poles. And as a result, the magnetic field becomes more twisted and complex, causing the chaos and activity we see now. Eventually, the sun's polarity flips entirely, and our sun returns to its more placid phase. Researchers say it will be impossible to identify the exact peak of the cycle until at least a year later. But what they can do now, said Lisa Upton, co-chair of the Solar Cycle 25 prediction panel, is compare the shape of the gradual increase in sunspot numbers over the last few years, from about 2020 to 2022, to the shape of previous solar cycles. That comparison and the current data show that the sunspot levels have begun to even out instead of continuing to climb. It's all down here. From here, maybe. Don't trust your own eyes, they say. On October 10, skywatchers around the world got their second glance or second chance of the year to watch a massive G4 geomagnetic storm light up the skies with aurorae. The previous storm in May 2024 reached G5 levels, the strongest type. Both storms followed a series of X-class flares from the sun earlier in the week. And yet, these storms are not in themselves proof of the sun's maximum state. Just as July can bring cool, rainy days and January might yield a day of t-shirt weather, the sun's weather varies hugely, even within a single cycle. A day near solar maxima might show no sunspots at all, and a day near minimum might shock with a powerful flare. Bill Mutag, Program Coordinator of NOAA's Space Weather Prediction Center, SWPC, points out that the famous Halloween solar storm of 2003, one of the most powerful on record thus far, occurred some 2 years after solar max, and the sun was at extremely similar levels as now for most of 2023, without the spectacular auroral shows. So, while it's certainly more likely to see strong solar weather near times of solar maximum, it's far from guaranteed. But with night falling earlier in the northern hemisphere over the next few months, it will remain a good time to watch for northern lights, even if you're a little down south. And that ends that article. But that also very much applies to us in one way or another. Let me find my other camera here. Good evening. All right, time is 10:22. Let me just check my email and see if we have anything that's come through from the masses. I've just got to activate my email. I did restart the computer a moment ago. Alrighty. vk3ekh@gmail.com. vk3ekh@gmail.com. We have two emails that have come in. We have one that's come from Stephen, VK3SBX, and he says, a very nice signal on 80 metres, 5 and 9 plus 25. All systems are go. Thanks, Steve. And we also have an email from Andrew, VK3KIS, and he says, listening on 80 metres, RST 5 and 9. He says, sorry, I missed the last broadcast due to... Oh, okay. Andrew, what have you been up to? All right. I hope that's... hope you're okay now. All right, thanks, Andrew. I hope you're okay. All right, any further emails, please send to vk3ekh@gmail.com. We have that inbox open as we speak now. And let me have a quick look at the chat room. We see that Dallas is there. G'day, Dallas. And Steve is also watching. Oh, there's a ringing tone in my ear all of a sudden. VK3TJS, Steve, and VK3 Mr. XL. G'day, Mike, just up the street. And if I have a quick look at the chat room, I see that everybody there, g'day, Brett, is there too. What's happened to all the activity on our chat room? The chat room used to light up. I don't know why it's down to only a few folks these days. Anyway, it doesn't matter. All right, back to the program. Where are we? VMix. Next on the scheme of things, yes, courtesy of astronomy.com. The latest X-ray observatory found a warped black hole disk and a supernova spewing iron, and it's just getting started. And this X-ray observatory is called XRISM, XRISM, and that stands for X-ray Imaging and Spectroscopy Mission. X-ray Imaging and Spectroscopy Mission, XRISM, XRISM. They just love their acronyms. The latest X-ray observatory found a warped black hole disk and a supernova spewing iron. The X-ray Imaging and Spectroscopy Mission, XRISM, isn't the first of its kind, but the state-of-the-art spectroscopic instruments on board have opened new doors for high-energy astrophysics. There is a picture of it here, so I shall throw that up on the screen. It's a funny looking image, but I think it's more of an artist's rendition than anything else. Yes, it is. It's X-ray mirrors and star trackers are mounted to the craft's front and shown in this rendering. It's a conceptual image, so it's not exactly the real thing. It's a conceptual image, but it will do to describe things. Active galactic nuclei, or AGNs, supermassive black holes that actively gobble material and shine brightly in the resulting chaos, have always held mysteries for astrophysicists. Now, a year after XRISM's launch in September 2023, its first results have revealed key findings about an AGN's structure and traced a supernova remnant by imaging the flow of nearby superheated iron atoms. The results come from XRISM's commissioning phase to test and showcase the abilities of the new orbiting observatory. More than 100 international researchers investigated XRISM's data to produce the results of 2 new studies. It is truly exciting that we are able to gather X-ray spectra with such unprecedented high resolution, particularly for the hottest plasmas in the universe, said Leah Corrells, co-author of both XRISM's publications and an astronomer at the University of Michigan. XRISM was built through a collaboration between the Japanese Aerospace Exploration Agency, JAXA, and NASA, with participation from the European Space Agency, ESA, and is meant to function in concert with its predecessors such as XMM Newton X-ray Telescope and the Chandra X-ray Observatory. The new observatory uses 2 instruments, including XTEND, 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 an imager focusing on the soft X-ray end of the spectrum. But researchers are most excited about Resolve, a spectroscopy tool with a twist. It's a microcalorimeter that measures not the X-rays as they enter the instrument, but how much they warm the small detector when they strike it. The incredible sensitivity of this setup gives Resolve unprecedented spectral resolution justifying its name and yielding highly detailed spectra with which to analyze X-RISM's targets. Resolve will allow us to see shapes of these spectral lines in a way never possible before, said Brian Williams, a X-RISM's project scientist at NASA's Goddard Space Flight Center. In a press release early this year, letting us determine not only the abundances of the various elements present, but also their temperatures, densities, and directions of motion at unprecedented levels of precision. To test the new telescope's metal, METTLE, metal, the power of Resolve was brought to bear upon a supernova remnant in the Large Magellanic Cloud called N132d, whose massive originating star collapsed in a supernova explosion about 3,000 years ago, leaving behind a hot bubble of gas in the interstellar medium. During the supernova, iron was released and heated to a staggering temperature of 18 billion degrees Fahrenheit, or 10 billion degrees Celsius. The study has been accepted for publication in the publications of Astronomical Society of Japan. At this temperature, X-RISM easily traced the iron elements and revealed that the shape of the SNR N132d is not the expected spherical bubble, but instead is torus, or donut-shaped. Additionally, X-RISM yields information about the speed and direction of the hot plasma. The research team was able to measure the speed and found that the torus is expanding at a rate of 2.7 million miles per hour, or 4.3 million kilometers an hour. These new observations showcase the mission's exceptional capability in exploring the high-energy universe. And there's another picture here that shows this donut, but it's more of definitely a conceptual design picture rather than the real thing, but it gives you an idea. Where is it? Let me bring that up so you get an idea of what we're talking about. So in this image, several distinct regions surrounding the supermassive black hole at the center of NGC 4151 are shown in this artist's concept. The blue region is material in the inner accretion disk just outside the black hole's event horizon. Just outside that lies the turbulent broadline region, and beyond it lies a donut-shaped torus, which is what the article was referring to. So finally, a bent black hole. Another early release study is also based on X-RISM's first look data and exposed secrets behind the AGN at the heart of the spiral galaxy NGC 4151. The supermassive black hole weighs 30 million solar masses and is located at about 62 million light years away. Prior radio and infrared observations had already shown that the accretion disk surrounding the supermassive black hole is also torus-shaped, as well as the material within the disk. However, with the advanced spectroscopic tools on X-RISM, researchers can now trace the distribution of plasma orbiting and falling into the black hole. The iron elements within AGN are the key ingredients for this and future studies to map out the structure of the accretion disk. Resolve is allowing us to characterize the multi-structured and multi-temperature environment of the SMBHs in a way that was not possible before. X-RISM is only now beginning its general observer go phase, when scientists worldwide can submit targets and study the results. The next few years will see a whole new X-ray universe open up for understanding. You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. Righto, Mr. Brash. Let me see. Courtesy of astronomy.com. Thank you, Mr.com. Where are we with the time? It is 25 minutes to 11. All right. Not much more to go, to be honest. Most powerful gamma rays ever seen in the galaxy centre detected by scientists. October 24. Courtesy of space, actually it's sciencealert.com. And we have 3 pictures associated with this article. In fact, the first one is really quite tantalising, as far as I'm concerned. It is anyway. I think we're still hanging in there on YouTube. Let me see. Where's the vMix and the picture that I want to show here, which is the first part of this article. Here it is, coming up on the screen as we speak. Righto. Most powerful gamma rays ever seen in galaxy centre detected by scientists. And the picture you're seeing there right now is a real image. It's no artist's impression. It is a picture of the galactic centre in radio and infrared. It is real. There's nothing fake about that. Bloody marvellous stuff, if you ask me. Although our galaxy's supermassive black hole is relatively placid, the centre of the Milky Way wherein it resides, is not a placid place. Its extreme location is rife with what can best be described as a shenanigans on an epic scale. Amazing I got that word right the first time. Shenanigans. It's not a common word for me to say. But now it can add a powerful cosmic accelerator known, this is the new word, okay? You're just going to have to put up with me if I get it wrong. Now it can add a powerful cosmic accelerator known as a Pevatron. I did try this before I went to air. Pevatron. That's the word. Pevatron. 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 To its list of japes. Oh God, what's that word? Japes. Japes. Anyway, Americans. An observatory high in the mountains of Mexico has recorded repeated emissions of some of the highest energy gamma rays ever recorded from a single point close to the galactic centre. The nature of this source, named HAWC J1746-2856, is unknown, but over a period of 7 years, the high-altitude water Shukhanov, which is HAWC, high-altitude water Cherenkov, that's the word, Cherenkov Observatory recorded 98 gamma ray events with energy levels exceeding 100 tera electron volts. These results are a glimpse at the centre of the Milky Way to an order of magnitude higher energies than ever seen before. The research for the first time confirms a Petravvolt, Pevatron source of ultra-high energy gamma rays at the location in the Milky Way known as the galactic center ridge, meaning the galactic center is home to some of the most extreme physical processes in the universe. And there's another picture here, which I think is this one. And that one there is the Crab Nebula. It's a remnant. What you're seeing there is a remnant of a supernova in the Crab Nebula, seen here in infrared wavelengths. And they refer to it as a pevatron. Pevatrons, P-E-V-A-T-R-O-N-S, pevatrons, are what you get when you mix cosmic rays, mostly charged protons, and atomic nuclei streaming through space at almost the speed of light, and giant natural particle accelerators. Environments such as supernova remnants, stars being born, and the powerful magnetic fields around supermassive black holes can be pevatrons. Oh dear. If the particle accelerator is strong enough, it can accelerate the cosmic rays to extremely high energies, up to tera-electron volt ranges. That's 1 trillion electron volts. In spite of their power, such high energy accelerators aren't easy to find. A lot of those processes are so rare you wouldn't expect them to be happening in our galaxy, or they occur on scales that don't correlate with the size of our galaxy. For instance, a black hole eating another black hole would be an event only expected outside our galaxy. When the accelerated cosmic ray then deaccelerates suddenly due to an interaction with something else in space, like a magnetic field or a dust cloud, the energy it carries is released in the form of a gamma radiation. And gamma radiation cannot travel very far in Earth's atmosphere, which means we can't detect them directly from the ground. However, when they enter our atmosphere, their interactions with other molecules distribute their intense energy, breaking them into a shower of harmless low-energy particles. And these can be detected using underground Cherenkov detectors like the HAWC. Physicists can then reconstruct the gamma ray that produced the shower and even figure out where in the sky it came from. HAWC is particularly sensitive to tera-electron volt energies and has made several breakthrough detections, including the first detection of tera-volt gamma rays from the Sun. And there's just one more image here, which is this fella. And what you're looking at there is the Galactic Center radio arc. The Galactic Center radio arc. Amazing. A team led by physicist Soyonya Karakaran of the University of Maryland found signs of pevatrons in a wealth of HAWC data collected over 2,546 days. And interestingly, 98 of those signals seem to have come from a same point and source in the center of the Milky Way galaxy. Named HAWC J1746-2856, the accelerator spits out the most powerful emission ever observed from the galactic center. The team have yet to narrow down HAWC J1746-2856 identity, with no known supernova remnants coinciding with the source's location. There are two things in that vicinity that could be